You know when you go to the amusement park and you go stand in the line and you wander through all of the cattle paths and you finally get to the front of the line and you're next? You know how exciting it is when you're next? You know what's really cool? We're next. We get to do this. Isn't that cool? Welcome to the definitive deep dive into the .git folder. Woohoo! So here's the part where I tell you I am definitely going to post the slides on my site tonight. Have you heard that before? Well, sorry, in this talk there are no slides. But the code that we're going to look at, all of the tools that we're going to look at, is online right now. It's up here on this gist. Here's the gist here, and so all of the things that we're going to look at is right here. And if this URL of this gist is a little bit too weird, then that's totally fine. Head over to robrich.org. Let's go there. robrich.org. We'll click on presentations here at the top, and here is the person who needs to push refresh. And here is the definitive deep dive into the .git folder, and you can click on here and get straight to the gist. While we're here on robrich.org, let's take a look at some of the things that I've done recently. I'm a developer advocate for Shoreline. Shoreline makes it really easy to debug Kubernetes and virtual machine infrastructure. Docker has also given me some awards. Microsoft has as well. And I'm also a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver that completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp here in Sweden or wherever you traveled from, find me here at the event or hit me up on email or Twitter, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, Pro Microservices in .NET 6, that one just came out. That was really cool. I run a user group both in Utah and in Arizona. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air and they sent me a mug. Woohoo! So there's my claim to fame, is my coveted .NET Rocks mug. And if you'd like a .NET, no, I'm just kidding. So let's talk about the definitive deep dive into the .git folder. So I have here an empty folder, and let's go make that a Git repository. So to start off, you probably do something like this. You say git clone github.com/robrich. We're not going to do that. Or you could say git clone myserver.com. We're not going to do that either. Let's do this, git init. Now the cool thing about git init is that will create an empty repository here in this folder. So what was an empty folder now has a .git folder in it. Now I chose to view hidden files and folders. I went into view options and I turned that on. If you're on Mac or Linux, folders that start with a dot are hidden by default, so you'll need to go turn that on. But here is the .git folder, and this is the database for Git. Now I'm going to open this up in VS Code because we'll get to poke at all of the things. Now I'm specifically opening up the .git folder, not the folder that it contained, because Visual Studio will, or VS Code will hide the .git folder from us in this list, and I really wanted to look at it. So let's take a look at all the stuff that we have. Hooks has some interesting things in there, objects, refs. For the most part, this is empty. Now, our task today is to open up each one of these files and talk about what they do. So let's do that. First we need to build up some history. So I'll come back over here, echo file1 contents, and I'll redirect that to file1.txt, git add file1, and let's git commit that with a message of initial commit. Of course, is that the rules that like every initial commit has to be named initial commit? Nah. File1 commit message. There we go. Now we've got a commit. So when we created this commit, we come back in here into the objects folder, and we can see stuff about the commit. Now, in this case, git log, we did commit 4df8e8bb. Have you ever had one of the managers where you're like, hey, can we deploy the latest? Yeah, I just built 4df8e8bb6e 2109D0F19947B8DF48. And they're like, yeah, and? But I want to deploy it. Well, can you deploy the latest? Yeah, that was it. So we have this git hash. And this git hash is actually the hash of the contents of the files together with hash of metadata, like the date, the parent git hashes, and the contents. So 4df8. So I'm going to wander here into objects. Oh, there's a 4D folder. That's pretty cool. 4df8. Ooh, there's the commit. That looks pretty cool. Let's take a look at that commit. Now, it is zlib compressed. So if we want to unzlib compress something or undeflate it, here's a Stack Overflow article that talks about it. Here's a Perl program to do it. Here's OpenSSL. I think that's kind of a brilliant way to use OpenSSL to unzlib compress something. A Python program. We can do some Git commands. That's pretty fun. Here's a C program. I actually built a program, little node program called unzipper. And here is unzipper, and what it does, it just, uses this zlib library, the inflate algorithm. I do split it by nulls so that we can see both sides of it. Otherwise, it will just stop at a null. So let's unzipper this. So I'm going to say unzipper.git/objects/4d/that. Unzipper is not in my path. Okay. That unzipper. Nope, that's not it. CMD. Okay. .git/objects/4d/f8. Are you going to be that way? Well, this may fail. And we may just go straight to the git command. And that's totally fine. Unzipper, you have failed me. Well, maybe we have to go and use OpenSSL for that. OpenSSL could be really awesome here. But there is a git cat file here that can do interesting stuff. So git log, git cat file. We can look at the type of it. So let's look at the type of 4df8. And it is of type commit. Let's take a look at the contents of it. Git cat file -p 4df8. And here is the contents of it. Okay, so this is the commit message that I gave it. That's great. Here's the committer name, email, date, time, time zone offset. That's pretty cool. And it references this tree node. That's interesting, AD88. Back here in the .git folder, here's an AD folder, 88. And so here is our tree node. That's pretty cool. Well, it is also zlib compressed. It's actually double zlib compressed. So let's get cat file, and we'll look at the type of it. The type is of this commit. It is a tree node. And then let's get cat file. We'll look at the contents, which of course is -p because spelling is hard. Thank you, Linus. And the contents of it says, here are the files in my working directory. So right now I have exactly one file in this working directory. I just have file 1. Here's the file permissions on it. And here is the blob node associated with that content. So if I say git cat file -t of that blob. It is, of course, a blob. Let's take a look at the contents of that. And nope, not -c for contents, but rather -p for contents, because contents, of course, starts with p. And here's the contents of it. So we have this commit node that references this tree node that references this blob node that includes the contents of our file. Commit nodes, tree nodes, and blob nodes. Cool. Let's create another commit. Echo file2, we'll redirect that to file2.txt, git add file2, git commit-m, file2, git log. We now have this commit, A868. So here's that other commit. What's it going to reference? Well, let's take a look at that. Git cat file-p. It references this tree node. Git cat file-p. There's the tree node, and it references this blob. Nope, I want this commit here. Git cat file-p, and it references this tree node. Git cat file-p, and it references two files now in my working directory. We saw file 1 previously, and here's file 2. Git cat file-p, there's that file. So now that we did 2 commits, we have 2 commit nodes, we have 2 tree nodes, and we have 2 blob nodes. And in fact, this is referencing the parent that we saw previously. So the hash is the hash of the contents, all the blobs, but it's also the hash of the parent node together with the parent nodes and the tree node. So echo file3. Let's redirect that to file3.txt, git add file3, git commit-m file3, and git log. We now have 3, which means our folder is getting pretty busy. What's interesting here is that for each of our commits, we end up with a tree node and blob nodes associated with the content that we committed. And so I think it's kind of brilliant that the first 2 letters of that commit ID is the folder name. That makes sure that we don't end up with too many files here in our folder. So now browsing that's going to be kind of a pain. So I actually built a really cool program here, Git Explorer, that allows us to be able to visualize not just the commits, but also the trees and the blobs underneath it. So I've launched that here, and I just launched it and it did its thing. And so let's take a look at this repository so far. Okay, so here's the file 1 contents, file 2. Well, let's show the types so we can kind of see it. Okay, so here's a commit node. There's file 1 commit, file 2 commit. I think I'll show it alphabetically and I'll show some tags. So there's my latest commit and it references this tree node 06. So there's that tree node. There's now 3 files in it. File 1, file 2, and file 3, 7C. I can see there's file 3 contents. Instead of showing it alphabetical, I'm going to show it parent-child. I'll show the lines and show the tags. So we can see this commit. This commit was on top of this commit, on top of this commit. And we can see that as it creates this tree node on this latest commit, it references these 3 files. Here's 1, here's 2, and here's 3. So we don't need duplicate copies of those files. We just need to reference the blobs that were already committed. So that's pretty cool. Let's do this. What happens if I were to say, create a folder? Folder, and let's echo file3 into folder / file3, git add folder / file3, git commit-m file3 in a folder. And that's why we have quotes around it in case I happen to put, say, a space in the middle of my message. Let's come back here and refresh this site. Show the type, parent-child, show the line, show the tags. Now we have this commit that references this tree that says, oh, hey, by the way, I have a folder inside me. So that folder is right here, and it includes the file3 contents, which, by the way, is this exact same blob that we already built before. We don't need another copy of this file because we, well, didn't change it. It's exactly the same file. The fact that it's maybe in another directory, renamed it, is just kind of gee whiz there. So for example, if I rename the file and you change the file, that's why Git can merge these things together in a really elegant way. So let's do something else. Let's say echo file4, redirect that to file4.txt. Let's take a look at when these things appear. So if we refresh this now, refresh, show the type, parent child, show the line, show the tags. Nope, nothing's changed yet. Git add file4. Let's refresh it again. Now we haven't committed yet. We've only staged it. And we see this. But I didn't commit it yet. Why do we already have the blob? Well, I did stage it. What if we changed that file? What if we modified it? We continued doing it. How do we keep track of the staged changes? Well, as we stage it, we create a blob node here in our repository. Now, if we don't end up using that over time, that might get garbage collected. If it's been older than 2 weeks and it's not referenced by anything, then that will get deleted. But for now, it's just right there. Okay, so now let's git commit -m file4. And now that we've committed it, we'll come back here and we will see that now it is a full commit. Here's the tree node that references everything in my working directory. It shows all the files here. It also shows that folder. Hey, we don't need a new tree node. That one didn't change. The contents of this folder are exactly as they expect. And now we reference that blob that we had staged previously. So when we stage it, it will put that content inside the blob node. And then once we commit it, it will reference that blob node elsewhere. So let's create another file. Echo file5 into file5.txt. Let's pop open file5 here. And we're going to code some. So some code here. For those people who really like semicolons, here's some of those. We'll have some curly braces, comment here. Some secrets here. Oops, I committed some secrets. Git add file5, git commit -m, definitely didn't commit secrets. And let's pop open this thing, show the type, parent child, show the line, show the tags. Oops. I committed a secret. That's okay. I'll just come in here and I'll modify that file. I'll go remove the secret. And let's stage that again. Git add file5, git commit -m, fixed it. And yeah, I could go through and squash them back together so I can pretend that that wasn't a thing. But there is a --amend that will do that for me. So I just modified that commit in place. Git log. Ooh. We just landed in VI. You know what's a really cool random number generator? Put a junior dev in front of VI and ask them to quit. The magic key, by the way, is Q. Okay, so let's git log --1 line. That looks a little better. Hey, I fixed it. No secret. Kinda. Let's refresh this. Show the type, parent child, show the line, show the tags. here is the commit. Everything is fine. It references this file. Everything is fine. My secret is gone. There. Git is great. Git is this wonderful double entry bookkeeping system where anything that you put in Git, it's going to store there and keep it for whenever you need it to make sure that you always have your secrets really exposed. I would propose that if you commit a secret to Git, your secret is lost. The only way to solve this is to roll the secrets. Yes, on Friday at 5 o'clock. I'm sorry, you committed it, your secret is lost. Yes? How about reflog? Great question, let's come back to that. So how can I get rid of the secret? Yep. Ooh, good call. Let's reset -- hard. Git reset -- hard. Git checkout head. Git reset -- hard. Show the type, parent child, show the lines, show the tags. Oh, I didn't show the type. Sorry. Well, what if I rebase? Git rebase -I. I don't know. That one. Yep, that looks good. Git log, one line. That looks good. Show the type, parent child, show the lines, show the tags. Nope. If you've committed it to Git, Git will save it. Now in time, because we have no branches pointing to this commit, it will eventually prune this, but not right away. It is in source control, and the only way to solve this is to rotate the keys. So what if we go here, 8b92. So let's come here into .git objects 8b92, and we'll just delete that node. There we go, that'll fix it. Show the type, parent child, show the lines, show the tags. Yeah, this thing is referencing a file that doesn't exist. Git status, git add file 6 to file 6.txt, git add file 6, git commit -m file 6. Git checkout. This one. Ooh, we just hit a kind of interesting thing. We're in a detached head state. So, I'm in zombie land? How did we get here? Well, I checked out a particular commit, and what it's telling me is that, well, my head is not pointing at a branch. So let's put this commit back only because that'll do bad things. And let's talk about branches. So we looked at the objects folder. That was really cool. Let's take a look at refs. So we have refs heads main. Refs heads main points at 007C. So if we take a look at git log, one line, we don't see it. Okay, git log -- one line -- decorate. That will put in the branches. In this case, I already have the branches because I chose to show them all the time. So then let's say graph, which will give us this cool ASCII art here. And I'm also going to say -- all. So git log -- one line -- decorate -- graph dash dash all will give us this, and we now see that main is pointing at 007C66F, which is right here, 007C66F. So if we wanted to say move head to point to this commit instead, we could just change this file to do that. And now git log dash dash one line dash dash decorate dash dash graph dash dash all, main is pointing here. Now, the only way you can break Git is by changing the files inside the .git folder. So don't do that. But that's basically how this file works, is it just points out whatever commit is at that branch. So let's put it back. And now if we take a look at it, now main is pointing where we expect. We also have one that is called head. And let's say git checkout main. And now we have this head file. Of course, it's not in the refs folder because consistency is hard. But it basically says head, where my working directory is at refs heads main. Okay, so basically it just points to there. That's pretty cool. Let's do this. Git checkout, or let's git branch, new branch at this commit right here, file 2. So I will put it there. Git log dash dash one line dash dash decorate dash dash graph dash dash all, and here's our new branch that points to this commit here. So back in refs heads, we now have new branch that points at that commit, but our head still points at refs heads main. Okay, so let's check out git checkout new branch, and now head points at new branch, or main, and now it's pointing at main and new branch, and now it's pointing at new branch. I totally trashed my working directory as I did that, but that was pretty cool. Head just points there. So let's git checkout this commit. We are in a detached head state. Now in a detached head state, everything still works, so let's echo file 8 into file 8.txt, git add file 8, git commit dash m file 8, git log dash dash one line dash dash graph dash dash decorate dash dash all, and it still works. So what is this detached head state? Why is it so traumatic? Well, if we pop open head, head points at a commit. Well, if head points at a commit, not a branch, and we were to switch off of this and get long enough to collect the garbage, then eventually this commit might be gone. Git is saying, hey, just in case, I think you might want to create a branch here. So let's say git checkout dash b, which will both create the branch and check it out, branch 2, and now we are no longer in a detached head state. Head is now pointing to a branch. So refs is really cool. It keeps track of our human readable labels, which is a little bit easier than asking the boss if I can deploy 93F226D. I'll just call it branch 2 or main or release. These are labels that we use. Well, what if we want to mark a point in time? Let's say git tag v0.1, and I'm going to put that where main is. So I've got that tag now, git log dash dash one line dash dash graph dash dash decorate dash dash all, and I see this tag. And the tag is just marked as something here in this tags folder. It just points to that commit where we expect that stuff to be. Okay. Oh, thanks, VS Code. I really want to help with a .1 file. So refs. Refs just point us to the commits that we need. The only magic one there is head, which doesn't happen to be in the refs folder, but that's kind of silly. So we took a look at refs. Let's talk about how we might talk about remotes. Now, I have another folder here. Let's close this one. this server folder, and it is empty. So here we're in the server folder. And now let's create the server side of this. Last time we said git init, and we didn't do anything else. This time let's say --bear. Now what's cool about bear is that it creates the contents of the git directory, but not the git directory itself. So we don't have a working directory, we don't have a checkout area. So here in our folder, we can now see the contents of the git folder, but not the git folder. This is perfect for servers that won't have a checkout directory. Now that I've got that server in place, let's come back here and let's say git remote add origin. Why would I call it origin? I could call it server. I could call it foo. Maybe I'll call it Azure. And I'll give it a path to my server. github.com/ nope, I don't want to do that. Control C. Git remote add origin. I could also pass it the path to some server. I won't do that. Git remote add origin. I could also go C:/my folder and pass it the path there. But in this case, my origin is up one directory in the server folder. And I can give it that remote path as well. Any of these mechanisms of referencing that remote will do that. And so when I said git clone, it actually did the git init and the git remote add origin all in one go, which was pretty cool. Cool. Now that I do that, git log -- one line -- what's the next argument? Great. What's next? Decorate. Oh, if you get nothing else from the talk, get that command because that is amazing. Great. So now I don't see anything with the remote. I haven't connected to it yet. Git fetch origin, and I can see that I still don't have any content on the server. So let's send some stuff. Git push origin new branch. Now it always bothered me. I'm like, I'm going to push new branch to the server named origin. Why would I say origin first and then new branch? Well, it's because I can also push other things too. So let's also push main and v0.1. And so all of those things now go to the server. So on my client, I have all of these objects. And now on my server, I also have all of these objects. So why do I say that the moment that you commit something to Git, it is lost? You may have something automatically pushing those changes to the server on the off chance that your machine might have a problem, or the fire alarm went off, or you forgot to back up. It will automatically push those to the server. If you have that automatic thing, the moment you push commit, it automatically went to the server. And the server has those objects too. Now in this case, the server doesn't have all of them. It only knows where main and new branch and the tag is. So here on the server, let's open up the server in VS Code. Show more options, open with code. Here's our server over here. We only have main and new branch. We don't have branch 2. And if we were to look through the objects, we don't have 9.3. We only have the others. So let's push the rest. Git push origin branch 2. And now if I refresh this here on the server, we now have 9.3. Cool. So we synchronized our content between client and server. Let's go back to our regular one, and we'll take a look at the refs here. We now have a remotes folder. Inside the remotes folder, we have a folder for each remote, in this case origin, and here's where I last saw those branches. Similar to the remotes that we had inside of our local machine, these are just where I saw the server last. Excellent. So the refs folder, that is pretty cool. We also want to take a look at logs. Now we talked about the ref log before. I've also heard this referred to as ref log. I can just see this cat of nine tails and I'm like, so I really want to get back to that one commit that I lost because I'm going to say git checkout main, git branch dash d, branch 2, git log. Oh, I already pushed it. Okay. Git checkout branch 2, git add echo file 9, point it to file 9.txt, git add file 9, git commit dash m file 9. Okay, so now we've got some local changes. Git checkout main, git branch dash d, branch 2. Git log dash dash 1 line dash dash graph dash dash decorate dash dash all, and branch 2 is gone. My changes are gone. Kinda. Now Git stored them. If we come back to Git Explorer and refresh it, we can see that we still have that content in place. Here's the commit that we just did. It just doesn't have any branches pointed to it. Well, how do we go find that commit? That's where reflog can be really helpful. Inside reflog is a log for each of the refs. So here's main. Main started out nowhere and went here, and then it went here, and then it went here. Here's new branch that did it as well. We also have some for our remotes, but we also have one for head. Here's where head has been. Now browsing it this way is kind of a pain. Oh, somebody has a comment there that VS Code doesn't like. So let's say git reflog. Here's where I've been recently. So how do I get back to that file? Well, it's right there. Git checkout that commit, git log dash dash 1 line dash dash graph dash dash decorate dash dash all, and we're back at our commit. Reflog is a great way to be able to find those pieces and get back exactly to where we need to. Now we're in a detached head state. Git was really grumpy at us here. We know how to fix this. Git checkout dash b branch 2, and we're back. Reflog is a great way to go find the refs. It's a log of the refs, of all the branches, tags, and remotes. Cool, so we wandered through the logs folder. There's some other logs that we'll jump into as well, but let's next look at the hooks folder. The hooks folder, here's some shell scripts. This one is actually a Perl script that will run on various events. This is great for automation. I want to lint my code, I want to run unit tests before I push, so I can create these commands to be able to do something. Now right now they have .sample at the end, so I'll just go reach into my stash and I will go grab some hooks that I built previously and set them here into this folder. And each of the hooks that I'm adding is just a script that will echo the step name and all the arguments passed to it, just so that we can see what's going on. Now this is great for automation. So let's say echo file 10 to file 10.txt. No commands here. Git add file 10. Git commit -m file 10. Ooh, we got a pre-commit hook. We got a prepare message hook. Here's the argument, this .git/commit edit message file together with the message. We've got a commit message hook. We've got each of these hooks that may be able to do interesting things. So we might say, for example, let's validate the commit message. Are we using the format that matches the format that will automatically generate the change log in our organization? If not, maybe we can reject this commit. Git push origin branch 2, and we see a bunch more hooks. Pre-push hook. Have you ever done a git push to, say, Netlify or to Kudu, Azure Web Apps, and it just does a bunch of stuff? They have a post-push hook that goes and deploys your code. They have one of these on the server that just listens for these events and triggers a script on their side too. Okay, so I've got my hooks ready to go. I've been able to craft these. I like how this hook is working. So I'm going to say git add.git/hooks/ pre-commit, pre-apply, pre-commit hook. There, I added that to my Git directory, git status. We can't commit files that are inside the .git folder. Yeah, bummer. And that's kind of intentional. If I could commit an object that then turned into an object, with the, that's kind of recursive. Here's a git hooks package that will symlink that .git/hooks folder into a git-hooks folder, and I can actually compare, define how I want that hooks folder to be. Now I can start to commit that. And there are lots of other packages. In Node, there's git hooks or Husky. In Python, there's pre-commit. Other languages like C# use pre-commit as well. In PHP, there's PHP git hooks or Grum PHP. There's a shell script called git hooks, which was actually rewritten as a Go program. I could also specify some config that just says, oh, by the way, the hooks directory is over there, but I also can't commit my config file. So you can go choose the package that best meets your needs. And what's really elegant about git hooks is that as I npm install it, it automatically creates those symlinks. So if you're in a Node program like I am, then you're going to npm install, you'll automatically get the hooks, and then you'll be able to use the automation that I've got in place. So hooks is great for that automation. Anything that we want to be able to do. Maybe we're linting our code on stage, or maybe we're validating our commit message, or maybe we're running the unit test, but only on those files that are about to get pushed. Each of those steps we can automate so our machines can kind of help us do more efficient stuff. So we looked at refs, we looked at objects, we looked at logs. Let's take a look at info. Now here's an exclude folder. It's all the things that we don't want to commit to Git. So if we're in a .NET project, we'd probably exclude bin and obj. If we're in a Node project, we'd exclude Node modules. If we're in a Python project, we'd exclude PyCache. And of course, I've crafted my git ignore list, so I'm going to come in here, git add .git/info/exclude git status, and I can't commit that either. Good thing there's actually a git ignore. So if we craft a .gitignore file here inside of our content instead, then I can actually commit this .gitignore file. So where we could use this exclude file, I would invite you not to. Let's put this inside of our .gitignore file, and now we can commit it. Git status, I can see that I've got a gitignore, git add.gitignore, git status, git commit, git ignore. So yes, there is a file here called exclude, but let's never use it. It's one of those files that it's just like, yeah, maybe Linus was making stuff up. Maybe this was an experiment. Speaking of experiments, here's a description file. Has anyone ever used Git InstaWeb? Yeah, me neither. So what is Git InstaWeb? Git InstaWeb is a web server built into Git that allows you to host your repositories. You just launch Git InstaWeb and you now have a web browser, and this is the description that shows up in that website. Now, it works on Linux. It isn't included in Git for Windows, and we've never used it because we use GitLab or GitHub or Bitbucket or these other cloud services. So description is that Git InstaWeb description, and you'll probably never use it. Temp files. Here's fetch head. Here's head. Nope, that's not it. Here's orig head. Commit message. These temp files are the things passed between those shell scripts so that we can then edit that. In the middle of the shell script, I might want to rewrite this commit edit message, or maybe I just fail the commit based on that. So we've got some temp files in here. Over time, we may end up with a whole lot of objects here. We just did a dozen or so commits, but under the hood, Git will run git gc periodically. If it notices that the repository needs it, it's changed enough, as you run these other commands, it will run that under the hood, and it will just go through that objects folder and pack them into these pack files. Now, one of them is a pack file, which, by the way, is zlib compressed, so all of our commits look like that. But Git will transparently uncompress that as necessary. So though we don't see the files inside our objects folder anymore, we can still interact with them in really elegant ways. So git log --one line --graph --decorate --all, and we still have our full history. There's this index file. There's also an index file right here. And this index file is kind of interesting. This index file powers git status. What is in this index file? Well, this answer is actually really helpful, where it kind of diagrams all the pieces and all the bits of all the things, and yeah, it's pretty intense. Here's Gin, which is a Python program that allows you to browse through this git index file. It knows how to read it, and it can just output it. Or, and I love that they modified this answer with this, you can use the built-in git command, git ls files. So let's git ls files. We'll include stage. And so here are all of the, in this case, stage is 0 because we're not in the middle of a merge. Here's all the files in our working directory. If we wanted to quickly do a git status, maybe it would need to go through here, and it would say, well, here in this commit, what is your blobs? Did you modify it? Nope. Okay, what's your blobs? Did you modify it? And so it need to traverse through all of these things, diffing all the things. Well, what it does is it quickly identifies the hash of that file, so that when the time comes, we can just take a look at that file, hash it real quick, and say, did it change? So this index makes git diff really fast. Here's all of the files in the working directory as of the last time we committed. Let's modify a file. I'm going to come in here. Let's look at file 2, modified, git add, git status. We can see that file 2 is modified because the hash here no longer matches the hash of that file. Git add file 2, git commit -m file 2, and we can come back here and we can see that that file is modified. Show the type, show the lines, show the tags, and here is file 2 that's modified. Awesome. One more set of files in here that's really fun is the config files. Here is config. Now this config is all the details in this specific repository, and these override any settings in the system config. Let's open up that one. Here's the system one in my home directory. Do you remember, or the global one in my home directory, git config --global user.name. Do you remember setting this ages ago? What you were setting was this, user.name. And it is global because it's in the user-specific one, and it is therefore global to all the repositories that you have in your directory, user.name and user.email. And this one overrides any settings that you have in the system one that is in the directory where you installed Git. Mine happens to be in program files. So these are all the options that I chose when I installed Git, and then I override that with anything user-specific, and I override that with anything in my local repository. So let's say I'm doing mostly open source work, and so I want to use my personal email, but then I also want to use my work email for my work repositories. Okay, so let's go grab these settings, and we'll set them in the repository, and we'll change our email address there. So now if I say echo file 12 to file 12.txt, git add file 12, git commit -m file 12, git log. I can now see that I'm using my business email for this commit. Now, I didn't rewrite all my old commits, so all my old commits still use my personal address, but I can set any setting that I want here in this config, and that will override any settings that I've set in my global one. So what settings do I have in here that are interesting? Now, I chose to use VS Code as my editor, so I don't end up in VI. That's always fun. But git log --one line --graph --decorate --all. I created an alias for that because that's a lot to type. So I instead said git hist, which does that for me. Have you ever been in the middle of a thing and you go then pop open the editor and you're going to go look at the file and then you come back and you say git status? I have an alias right here that says if you type the command git, just open a new shell and run that command. And that works just fine too. So this config file is really great for lots of options. One option that I have here is the autocorrect. So it's not uncommon that I will type something else and it'll go, hey, I'll help you. So that is the tenths of a second that can automatically do that. I also set my default branch to main because Black Lives Matter, so I'm no longer using uninclusive terms there. And we can also include other things. I've set my merge and diff tool, and that's here in the config file. So we got to look at lots of different types of files. Here's a blog post that nicely summarizes everything, and this is in that gist as well as a blog post where a friend of mine, Eric Potter, created an infographic that kind of shows all of these pieces. And all of these are summarized here in this gist, where we can take a look at all the things, including the Git Explorer, and that is up here on this gist. Or you can grab it really easily from robrich.org. Click on presentations. We didn't run all of the commands inside of Git, but we did take a look at every file that is inside that .git folder. Hopefully this helps you get past just the commands that you have stuck to that post-it under your keyboard and lets you kind of embrace some of the things of Git. This has been a lot of fun showing you the internals of the .git folder. Thank you for coming.